Namaste students. In this category of Lewis dot cross structures, we proceed further with some more examples. Now I'm discussing molecule of PCl5, SF6, IF7, phosphorus pentachloride, phosphorus pentachloride. This is sulfur hexafluoride, sulfur hexafluoride. Iodine heptafluoride, iodine heptafluoride. Now what we need is atomic number and the configuration. Atomic number of phosphorus 15. So the configuration becomes 2, 8, 5. Chlorine atomic number 17. So the electronic configuration becomes 2, 8, 7. Sulfur atomic number 16. So the configuration becomes 2, 8, 6. Fluorine 9. So the configuration becomes 2, 7. Okay, that is how we have to proceed. You can, I'm just waiting for 30 seconds. You can write. Okay, now I'm writing phosphorus in the center and 5 chlorine atoms. Okay, now cross for phosphorus and dot I am using to represent electron of chlorine. So chlorine has 7 in the valence shell. Same way here, chlorine has got 7 electrons in the valence shell. Just complete the structure. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And same thing for this chlorine atom. Out of 7 electrons of chlorine, 1 electron is taking part in bond formation while the 6 electrons are left unused in the form of 3 lone pairs. See children, this is the bonded region of phosphorus. But if you see carefully, you observe that phosphorus is not having 8 electrons in its valence shell in PCl5, but surprisingly it has 2 to 4 to 6 to 8 to 10 electrons. So phosphorus in PCl5 has 10 electrons. That is more than an octet. When the central atom in a molecule, has more than an octet, then it is said to have expanded octet, and they are stable even though they violate octet. rule. Let us see SF6. Sulfur, fluorine, in here, tumor, and one more. Now, fluorine has 6 electrons in the valence shell. Correct? And fluorine has 7. Same way here. Same thing here. Careful when I make the structures. Correct? Now see, this is the bonded region. Carefully. This is the, and here, just taking it little bit this side. This is the bonded region of, here also one more. Correct? And this is the bonded region of sulfur. If you see carefully, 2 to 4 to 6 to 8 to 10 to 12. Sulfur in SF6 has 12 electrons. Surprisingly, this is also an example of expanded octet. Sulfur has more than an octet. Still, sulfur hexafluoride is stable. Let us see the example of IF7. You know, iodine atomic number is 53. So the configuration will be 2, 8, 18, 18, 7. We just shift a little bit this side, going out of the boundary. So 2, 8, 18, 18, 7. Correct? 2, 8, 18, 18, 7. Now, I'm making iodine, 7 fluorines, okay? Iodine has 7 in the valence shell. 1, 2, 3, 4, 5, 6, 7. Now fluorine, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Same thing here. 1 electron here. Same way here. And here. You need to have patience to make them. You can't be in a hurry. Now see the bonded region of iodine. Here it goes. This is the bonded region of iodine. How many electrons? 14 electrons in the valence shell of iodine in iodine heptafluoride. So I in IF7 has 14 electrons. Again an example of expanded octet. So these molecules, phosphorus pentachloride, sulfur hexafluoride and iodine heptafluoride have more than an octet. With respect to their phosphorus, sulfur and iodine atoms, still they are stable and they violate the octet rule, still they are stable. That was really interesting. Now we can just understand this is for chlorine. This is, just go a little ahead. This is for chlorine octet complete. This chlorine octet complete. This chlorine also octet is complete. Same way here, chlorine octet is complete, and same thing here. Exactly similar will be here. This is how the octets are complete of fluorine atom, like this. Correct? Same thing here. This is the region of this fluorine. This is the region of this fluorine. Same way here and here. And then we have this, and for this fluorine, and finally. So that was quite interesting. When you look into the book, you find it difficult how they have made the structure, but I made all the structures in front of you. So I don't think at all that there should be a problem in understanding them. Hope you understood the lecture and you practice these structures. Try to practice the structures at least 2 3 times on your own, and then you will have mastery on them. Okay, bye bye. Take care. Love and blessing.